Hello students, this is the second to last video of the unit. This is video 1-11. 1-12 will be the actual unit test, me going over that. So let's go, flippers. So question number 1, and many of you got through this first page, but I'm going to do every problem so that you know how to do it. So here what we want to do is we want to look at number 1, and it clearly says that they want us to find the length of a segment. Okay, and we want to find the length, you need to take the coordinates you're given and find the distance. So I've got 4 and 1. I'm subtracting those, and then I also have 7 and 11. So I'm going to subtract those. And then when we combine them and add them together, we end up with radical 25, which is equal to 5. So the answer is 1. Number 2 here clearly wants the midpoint of the segments. And clearly none of these answers are right because they're not points. So we're going to add the x's here, divide by 2, add the y's, divide by 2 to get the point. We end up with 2 over 2, which simplifies to 1, and 3 over 2, which simplifies to 1.5. So this is the coordinate of the midpoint. For number 3, the tricky part about this is that they say JK bisects. So when that happens, that means that JK is actually a bisector, and it's cutting these into 2 equal pieces. That means that basically now both of these equal each other. So I'm going to just substitute in 6x plus 2 and x minus 6. Set them equal to each other and solve for x. Here clearly x equals 4 after you go ahead and solve it. And now we need to substitute back in and find LJM. If x equals 4, plug in 4 for x, I'll get 26. And clearly, since this is congruent to this one, this other piece is also 26. And 26 plus 26 is going to give us 52. And that's our answer, 52 degrees. Number 4, what is the length of the segment whose endpoints are -1, 9, and 7, 4? Clearly, I'm going to subtract the x's, -1 minus 7, and subtract the y's, 9 minus 4. And then simply simplify. This clearly simplifies to radical 89, which is our answer for number 2. Number 5 is very similar to number 3 on the previous page. Again, trying to figure out the angle. Clearly, we can see here that angle LMO plus angle OMN equals LMN. So here, this is what I wrote out. Now we just want to substitute in what we know. We're also told that this is a bisector, which means again that these 2 angles are going to be congruent. So here we go. If we set these equal to each other and solve for x, clearly x equals 10, but they don't just want to know x, they want to also know L and N. So substitute back into the equation x. So clearly 10 plus 105 here will give me 115, and over here 16 times 10 minus 45 will give me also 115. And then they want to know the whole angle. They want to know the big one. Since they're both 115, they should add up to 230. So those are my answers, 230 and 10B. Number 3 is an example of a construction where if you had a compass, you'd actually sweep here, and then you go there to this spot that we were just intersecting here, and you'd sweep again. You'd sweep twice, you'd sweep here, and you'd sweep there. And then this ray would actually perfectly cut the angle in half. So that's actually the right answer. Number 7. Name the angle supplementary to COD. So here's COD. And supplementary means it adds up to make 180 degrees. So the angle that could work are a couple of them. We could have number 8 and 9 are kind of a bonus here. Multiplicative inverse really clearly means multiplicative, which means you're going to have multiply, which means that it has to be multiplying. And inverse means you're going to have the opposite. So if you have 3, the inverse of 3 is 1 over 3. And if you have 2/3, the inverse of 2/3 is really 3 over 2. Okay? So you need a number and its inverse. Here, we don't have any fractions, so we don't have any inverses there. We don't have any fractions in 3 or 4. So 2 is actually the inverse because x is really x over 1, and times 1 over x is going to be 1. A number times its inverse is always going to be equal to 1. Additive inverse is a little more straightforward. Again, this would be 2/3, and then plus the opposite. Whatever makes this equal 0. Whenever I add to 2/3 to get to 0, that's its additive inverse. And that would be negative 2/3. Number 10. What is another name for a plane? Remember, a plane can be named by 3 capital letters, so it couldn't be B and it couldn't be A. And they have to be non-collinear, so they can't be on the same line. So BAD is clearly not on the same line, but BAC is, so BAC is wrong, and BAD is right. B, which is the name of array with endpoint A? So we're looking for array where the endpoint, okay, the terminating point is A. So let's look at AD, CA, BC, and AD. And our answer clearly is going to be D, because the endpoint for array looks like this. Here we go. AB, where this letter here in this spot represents the endpoint. The other point goes on and on forever on that end. But this is kind of the terminating spot. Looking for VAs, SAs, supplementary angles, and adjacent angles. So VAs here in the picture would be angle 4 and 6.
See you Monday.
The SAs would be 4 and 3. And the adjacents would be also 4 and 3 or 5 and 4. Lots of different pairs. So this angle can have lots of different answers as long as for VAs, the angles are sharing just a point. And for SAs, the angles add to 180. And for adjacents, they actually share a ray. So here's some adjacent angles because they share this ray right here. This ray. 3, name the figure 3 different ways. So this is actually kind of cool because this is line segment. You can actually write it out. AB. It's also segment AB or segment BA. All those work. So I'm skipping 13 and moving to 14 because 13 won't be on our assessment. So here is this question. Midpoint is here. The coordinate other and the endpoint is here. So what's the coordinate other endpoint? So imagine this. You've got AB and you've got M. So right now we're starting this problem off knowing where A is. Okay? And we know where M is. But we don't know B. So we're going to put in we know. We know if we had the midpoints, we'd have x1 plus x2 over 2. And that would give us some point. Some x coordinate. We also know if we had y1 plus y2 over 2, we'd have some other value, some other number. So let's figure it out. x1 is actually the endpoint we know, which is here, -3. We don't know the other endpoint, it's x value, so we'll just put it there, over 2, but we do know the x coordinate of the midpoint, which is here, that's -1. Same thing over here. We've got 2. Don't know this part. We do know divide by 2. We know it equals to 5. So now we just solve these two. So once we solve these two, we end up getting x equals -5, excuse me, and y equals 8. So that means our answer is 5, 8. And that would be our midpoint, -5. Now, last but not least, you need to make sure that tonight you review your interactive notebook, all your homework assignments, with 1 through 11, and be ready for your unit test tomorrow. Have a great night.